Okay.
Christian, I think it is
Now we
getting
are
recorded.
recording.
Yeah.
Great. So we hosted the Sustainable City Summit over 2 days, and we had different topics in this Sustainable City Summit. And the first topic we started with was energy. And now the idea is that we create a series of events where we highlight and spotlight the different elements of this Sustainable City Summit. Because cities are the human habitats, and this is where most of the pressure on natural environments are coming from. So it's where human beings are living, and we suppose that by 2045, 70% of the world population will live in large metropolitan cities. And when this happens, there will be even more pressure to the natural environments, to the natural ecosystems. So we have also a dramatic increase in demand for energy because of the way we are using energy. We use AI, we use blockchain, we use a lot of new technologies which require a lot of energy and more energy. And there are different types of efforts right now in the US. For example, they also talk about small and modular reactors combined with data centers. They today we will have a focus on hydrogen, and we will also hear about a very interesting initiative called billionBricks, which is tackling the affordable housing situation. So it's one of the biggest problems on the planet to provide affordable housing, basically. And combining affordable housing with climate impact. This is what Prasoon is doing. And Prasoon is sitting in India. And I will now pin him a little bit here so that we can see him more clearly. And then Prasoon, you can give us a story about billionBricks, and welcome to Tokyo again. Thank you.
All right. Thank you, Christian, for having me here. And then thank you to be here along with you, Joe, as well. Looking forward to the discussion with all the audience also. I mean, just to then build up on what Christian mentioned as the background for this session, I founded billionBricks originally in 2013, so almost 12 years ago. My background's in architecture and urban planning, so I worked on a lot of large urban development projects. I come from India, so I started working in India. Then I moved for my education to the US. So I worked on very large projects in Southern California around transit, around urban development, around housing. From there, I moved to Hong Kong. So I worked in Hong Kong and China. I also worked in Philippines and Indonesia. And then eventually I moved to Singapore. And not only did I work in Singapore on some projects, but also in Kuala Lumpur. I did quite a bit of work in Africa, then Australia, and then from Singapore and India as well. So I'm quite familiar with how the world has really evolved in terms of cities. I'm now 47 years old. So I've kind of lived in big cities, including Delhi, which is my home town, over these periods. And I've seen in most cities that I've lived in, which are in developing countries, the quality of life has actually declined. So when I grew up as a kid, the city was far more green. It took less time to go from one place to the other. It wasn't as wealthy as it is now, but it was cleaner, less pollution, less slums, more access to education and healthcare, less crime. So as we've become a much larger city, as we have more wealth, surprisingly, the quality of life has not increased. And the second part is that as we start putting in more money in development of these cities, in some of the things that Christian mentioned, such as AI, such as data analytics in cities, such as new types of jobs, data centers, etc., I find that we are not able to solve the old problems that exist in these cities, such as housing. And we are kind of moving forward in the other direction. And as a result, the gap in trying to solve the old problems and the excitement which the new stuff brings in is really keeping the old problems totally stuck. And we talk a lot about them, but we do very little for them or nothing at all. And that's why a lot of people call affordable housing as a wicked problem, which is too complex to be solved. But I beg to differ. I think if we apply the same kind of impetus that we do on other areas, the kind of money, billions and now trillions of dollars going to other spaces, if we put that in here, and if we have the political will, and if we find it really important to do it, we will be actually able to do it. It's not a wicked problem. I think it's more our own consciousness problem that's creating this issue. The second aspect is that I actually founded an organization which was a nonprofit initially, focused entirely on solving the housing crisis in 2013. And I realized that there's more concern in the world about climate change as opposed to housing. There are about, in Delhi alone, the city I come from, almost 3,000 to 4,000 people die every year just because of living on the streets, because it's too hot or it's too cold. And that number has remained consistent for over 20, 30 years since I've been living in the city. And I find that while these problems remain, but we are now more worried about climate problems, which are probably will impact us in 50 years down the line. And the fact that we are putting in so much effort, conversations, money behind climate change got me to come up with an idea to say, how can I leverage on this momentum on climate change, but try and solve an age-old problem of affordable housing? And that became the basis of what billionBricks is today, where we are building net zero housing communities. And the way we do that is that we put a large number of solar arrays on top of the rooftops. So if we do about 1,000 homes, we have a 10 megawatt solar farm on the rooftops. And what that does is that it completely negates the carbon footprint of the homes, both the embodied and the operational energy. And we are then able to sell the solar energy to create an income stream for the homeowners that pays part of their mortgages. So about 15 to 20% of the home ownership cost, which is a combination of mortgages and electricity bills, are paid by us. So for people who we work with, whose incomes, household incomes would be somewhere around $400 a month, this results in an increase in their household incomes by about 10 to 12%. So you can imagine just by living in a house, if your income increases by 12%, that's a huge jump. I'm sure a lot of you and people like us also don't get those kind of jumps in our salaries as well. So there's a huge economic advantage to these whole income communities, while not being able to have any negative impact on the environment. What this allows also us to do is that we are able to attract capital which is dedicated for renewable energy into this space as well, into housing, which traditionally will not flow. So a key investor in billionBricks is NG, which is the world's largest private energy company, which would typically not invest in housing sector, but now to us, they're able to bring in as well. So we are able to unlock a lot of capital, which typically won't come in this space, and we are able to bring that in. So we are headquartered in Singapore. We are currently operating in the Philippines. Our goal is to build at scale, where our methodology could be adopted to do millions and millions of homes. So in Philippines, to give you a sense of scale, has a shortage of about 6 million homes. And if they were done as a billionBricks home with solar farms on their rooftops, Philippines would produce more renewable energy than what it can consume. So the impact on the society as a whole, on sustainability and the future of these societies could be tremendous, only if we are able to realize our mission at scale. And it will be able to offset almost 5 to 6% of the carbon footprint at the national level. So a lot of countries who are missing the targets with regards to Paris Agreement, and especially with now AI data centers, the amount of energy needed is increasing. So people are missing the targets that even corporations have pledged with regards to zero carbon. We think that we can actually overcome those challenges through this. So we operate in the Philippines. We are actually, as we speak, building our first community of about 130 homes. We've already started delivering our first homes as well. And we have a pipeline of about 1,200 to 3,000 homes that will come online in the next 3 to 5 years. We are also looking at new markets to enter as well. We are actively fundraising at the moment, both a combination of equity and debt. and I'm happy to take a couple of questions as well. My apologies, I have to kind of drop out soon out of this call, but I'm happy to take a conversation for the next few minutes as well. Thank you, everyone.
Thank you, Prasoon. It's always great to hear your amazing story about how you built all this. And yeah, so because Prasoon has to go back to his important lunch, we can ask him questions right now if you have some questions.
Hi, Prasoon. My name is Akira Hoshino. Thank you very much for wonderful presentation. I wonder if you have ever tried to enter Japanese market with your formidable idea. If not, why you focus your effort to the Philippines and other countries and not Japan? Any hurdles or obstacles?
Yeah, so I think the real answer to this question is that we are a very small organization today, and we went into Philippines for three reasons. One is that in Philippines, I had prior experience of working as an architect and urban planner, so I was quite familiar with Philippines. Philippines as a market is also has a very robust funding mechanism for mortgages. So affordable housing is easy for people to get, provided people can build it like us. And it has an energy market which is open, which allows for anyone like us to come in and quickly sell the energy. The last factor that took us to Philippines was actually the funding. So when we partnered with NG committed to invest along with us about $10 million if we would get into Philippines as a market. So we had access to funding to get into the market. We are very keen to explore other markets like Japan. We think this idea is not specific to a particular geography or region. I think it's quite expandable, quite agnostic, provided that we have a sponsor who can bring us into the market. We have been quite active on social media, where some of our videos have gone viral in the past. And we have actually received requests from Japan for a couple of projects as well. But as you would know, to develop a business, it requires significant financing. And we haven't had that partnership in Japan. So if that's a possibility, we would be very, very happy to explore that. In fact, some of our current investors do have active portfolios in Japan. So Japan would be a very, very good market for us to get in.
I didn't listen to all you said, but Prasoon was visiting Japan when was it? In March, maybe?
Yeah, I think a couple of months ago, right? March, yeah.
Yeah. And we visited JICA, and we also had a meeting with Uwe here, who is also here today. Yeah. If there's time for one more question, maybe? So, do you have more questions or? So basically, Prasoon, billionBricks, that's what he's doing. We have nominated billionBricks for the Earthshot Prize. This is Prince William's initiative, and we can actually renominate nominations as well. And sometimes, so for example, NFW, we had nominated a second time, and the second time they became finalists. So if billionBricks makes good progress, we can also renominate billionBricks. And Prasoon is also a member in the PDIE group. So we have a membership where we have many people globally involved. Thank you, Prasoon, and thanks for making time. Thank you so much.
Thank you, Christian, for having me. And my apologies that I can't be throughout this, but Christian can share my details, which is prasoon@billionbricks.org. Happy to interact or join on LinkedIn as well.
Yes.
And please have a good session for the rest of the evening. Bye-bye.
Thank you. Bye. Bye-bye.
I'll take a screenshot before I go.
Okay.
All right. Bye-bye.
Thank you. Bye. Bye-bye.
Bye.
So, by the way, Prasoon is also an architect, and Joe McDonald is also an architect, and he's a former Harvard professor, and he's an expert for energy efficiency and energy and buildings, basically. So he has already been speaking he flew in all the way from the US to speak at our event for the Sustainable City Summit at the United Nations University. And today we have you again here. So thanks for being with us. It's very early right now. What time is it now in New York?
5:57 a.m.
Wow. Okay. So you got up very early. Thank you so much. And you will show also some slides. And so please go ahead, introduce yourself and also the magnificent opportunities. Actually, Suzuki-san already arrived, but he was still talking on the phone. I wish that he could hear what you were talking about, but we have to catch up then in the panel discussion. All right, the floor is yours.
Great. Thank you so much, Christian. And thank you for inviting me. And it was such a pleasure to be with you a month ago in Tokyo. Um, so the last time I spoke with this group, the focus was on green hydrogen. We have been commissioned to build the largest green hydrogen plant in the world, and that would be in the United States. A little bit of background about Urban A&O. Urban A&O is a design firm that I founded in 2004, so 20 years ago, when I was on faculty at Harvard. We very quickly became known for our computational design expertise, but that shifted into sustainability and the drive to net zero. That position now drives all of our work. Yes, we're still focused on computation, but we are using our computational skills, and we're also using AI to help us measure and reduce the impact of our work around the world. So I have a team of designers around the world. I'm based in New York City, and we're 100% a remote workforce. We have several projects underway right now. And I have several design decks that I could share with you, and I'm trying to decide which ones would be the most appropriate. If we're going to be talking about energy and cities, I'll stop sharing for a moment. What we're finding, because we do work worldwide, is we're finding that that this notion of net zero and the notion of how does that impact our cities becomes very, very important. And so we've found that our biggest contribution to the built environment. I'm an architect, a landscape architect, and an urban planner. Our biggest impact in the city is to make use of new energy production. So I will quickly move through just because billionBricks spoke. I wanted to share with you very quickly a development that we're doing just in the Hudson Valley, which is just north of New York City. This project is meant to scale By that I mean it's a model that we have very carefully developed that we can deploy anywhere. And what you're looking at here is our carbon triangle. So this is how we choose materials at the firm. The lower you go on the carbon triangle, the less the unit that we're using is the GWP, global warming potential. And what you find is at the bottom, you'll see that there is a zero line, and then there are materials below the zero line that are carbon sequestering materials. So like what? So for example, cross-laminated bamboo is a great example. CLT. Actually, we're using straw for insulation. So here's the housing development in upstate New York. You will see that that it that there are no cars within this development. It's meant to be uh, a community, a tight-knit community that where parking would be on the perimeter under solar. And literally about a 3 to 5 minute walk to your home. Here's the site. So we call these, you can see the three clusters of residential developments. So we call them climate clusters because we're using a proprietary algorithm to drive them to net zero. And we do that by um, uh, not only with the materials we choose, but also the configuration on the site in relationship to the sun, for example. They are a kit of parts that are fabricated in a shop. When we do that, we eliminate waste. And we the erection time goes up. So they get trucked to the site, assembled, and then what we call fitted out. So you're looking at a Solidia concrete base, and then rammed earth panel walls, then soji wood, Japanese charred wood, and then on the top are Tesla solar shingles. Here is this the cement that we're using. So this particular product is fascinating. It came out of Princeton University. It is a concrete substitute. So the numbers to remember are 70% reduction in the GHG footprint. 90% of the water is recycled, and we save up to 30% of energy consumption. It also cures in 24 hours, not 26 days like carbon. So I'm just going to fly through and give you a few images. We're using reclaimed barn board on the walls and the ceiling, cork on the floor, and what you're seeing here is a terrarium that we drop into the units for additional natural light. Now, this is a great shot because what you're seeing are these solar towers, and they're bifacial solar towers that just simply sit in the landscape, and they are powering we use that power to power the homes. And that is how we get to net zero for a community development. The reason I'm showing you this project is because we just heard from billionBricks, and I thought that this would be relevant to this conversation. Um, uh, so we can back out of that. I do I think Christian wants me to talk about green hydrogen, which I'm more than happy to do. Um, uh, I'd be happy to take any questions about that community development in the meantime, as I'm looking for the we design data centers, and we design them using clean energy. Um, Although that design deck has escaped me. So, are there any questions about the Hudson Valley community development? Um,
I-
We have a little bit of an echo here, so now it's fine. Okay.
uh,
Yeah, we have somebody who might have been reacting to your hempcrete thing. Wanna
yes,
ask a
yes.
question or?
Yeah, I would love to talk about hempcrete. We're working with a group out of Los Angeles.
Can you turn on?
Yep, go ahead. I can't hear it. Yeah.
Can you? Okay, yes. Yeah, you can go ahead.
Uh, I'm sorry. Just give me a moment.
Yeah, pass on
Yes.
the mic. We have a question here.
Thank you, Professor McDonald. I have a question about cost. How does this your housing complex compare to the cost compares to the ordinary housing that doesn't really take doesn't care of the carbon reduction?
Right. One thing that we're trying to do is we're trying to develop communities that are just outside of the city. So we know our competitors who are national construction groups that just simply develop, very large swath. It's a very American condition. So if we were to take the city of Atlanta, for example, that city is probably the best kind of offender of urban sprawl. So in the United States, we need to get past this idea of the kind of the American dream, where you have a single family home, two-car garage out front, and then a driveway. And what's happening is in Atlanta, the sprawl is so great that it takes about an hour and a half to get home. So how do we compare from a cost point of view? Um, uh, we are the fact that everything is prefabricated in a shop. So not only does that reduce waste to about zero, we're also using those low carbon materials. So the cost of the units are extremely affordable. Because if you look at the assembly systems, I showed you that axonometric. Um, we're using very, not only are they low carbon materials, but they're, for example, reclaimed barn board on the interiors. Um, uh, there's, the cost reduction is huge on that. So not only are we cost competitive, with the larger developers. We actually are able to undercut the costs because of our because of the manufacturing process that we're using to build these homes.
That's great. So it's not only sustainable, but it's also cost competitive. That's
Yes.
that's
Yeah.
a very good thing. Good. So yeah, maybe we can you would talk a little bit about green hydrogen, and then we have Suzuki-san here, and he will talk about Advantage Partners, which is one of the oldest private equity firms in Japan, and
Well,
they
wonderful.
run a special hydrogen fund, and maybe so you can just talk a little bit about the hydrogen, what you have been also talking about at the Sustainable City Summit, and
Yes.
then we give it over to Suzuki-san, and then after that we have a little bit of a panel discussion with involving you from online and us here from Blink. Okay.
Yeah. Yes. So the company that our client what is the technical breakthrough that is being used by this organization is that they use bio waste to create green hydrogen. So what is bio waste? Bio waste would include crop uh, uh, excess material that would then go into an anaerobic digester and then be turned into energy, which would produce green hydrogen fuel cells. Um, I think it's important to note this, that with the current administration in the United States, um, uh, this project is dependent upon 45V, which is a section out of the Inflation Reduction Act. So we know that the House of Representatives has, by one vote, has passed the what's called the Big Beautiful Bill. It's now being rewritten in the Senate, and the survival of Section 45B is critical for this project to move forward. Otherwise, traditional financing will be used. And as I announced when I was in Tokyo a month ago, the second plant will be in Japan.
You're trying to share something?
Uh, uh, no, I'm not. I,
You said the second will be in Japan or in Tokyo?
yes, yes, it will. Yeah.
Okay. Was that all you say, or you're just looking for something?
I I am looking for something. I'd be more than happy to share this,
Yes.
which uh, it's our uh, uh, it's our data center design deck, and I can move it through it very quickly. Um, when we design data centers, we work in collaboration with WePro. So we do core and shell, HVAC and MEP, and Wipro provides the AI IT. Um, Throughout this deck, you will see examples of clean energy. So we are very much advocates for small modular reactors, which we talked about last time. So SMRs are kind of the way of the future when it comes to compact, safe use of nuclear. Um, um, some of you may remember that last year it was announced that Microsoft was working in collaboration with the organization that it's called Constellation, that rebooted one of the towers at 3 Mile Island. Now, the question became with as data centers now, 150 megawatt data center used to be considered a very large data center. And what we're finding now is we're finding 1 and 2 gigabyte data centers. And so why are people why are groups the hyperscalers? Hyperscalers would be Microsoft, Apple, Meta, and AWS, Amazon. Why are they building 1 and 2 gigabyte data centers? And the answer, of course, is AI. So now we become, for those of us in the sustainability climate space, that's very kind of disconcerting for us because of the massive carbon footprint that produces. So what we have been doing is we've been calling on these large organizations to publish their scope 1, 2, and 3. Scope 3 emissions account for about 93% of companies' total GHG footprint. We're calling on them to publish their scope 1, 2, and 3 emissions. Um, uh, by law in the EU, you must, but in the United States, it's only scope 1 and 2. So here's a second example that I'm showing you. Hydropump storage is also a clean energy production process. This is not a new technology, but it's now being used in data centers. And here we have green hydrogen fuel cells. And this is the product of the client that I was talking about with the green hydrogen plant. They will produce green hydrogen fuel cells. And what becomes important to that developer,
Japanese client or?
uh, uh, he's American, but he is Japanese, yes. And so what's important to those organizations are what is called offtake agreements. So this company has two offtake agreements, two offtakers, which are companies that will be using the green hydrogen fuel cells. Now, the contract with these are 10-year contracts, and the total value of those contracts is approximately $3.6 billion in the use of green hydrogen. So when we go back to the original premise of this talk, um, um, uh, which is the impact on the city of clean energy. Green hydrogen fuel cells can essentially power our cities with clean energy. So no longer do we talk about coal or diesel engines. We're now talking about wind solar, as you can see here in the slide, wind, solar, green hydrogen powering our cities. And this is all clean energy as we are making this massive, rapid transition to both electrify and decarbonize existing building stock. So we can talk about energy from a new building perspective, but we can also talk about energy from a decarbonization of existing building stock, which is actually the more responsible thing to do, is to decarbonize our existing building stock within cities, and to only build new when necessary. So we this is a very interesting company, Boston Metal. This is a company that came out of Sadoway Labs, Professor Sadoway at MIT. Let me get to the second slide. So it's a molten.
I spoke to Professor Salloway.
Did you? Yes.
Yes, last year.
Yeah. So they have found a way to uh, so currently the steel industry produces 3.6 billion metric tons of carbon dioxide uh, using MOE, which doesn't require water. They have reduced it to zero emissions. And remember, on the carbon triangle, steel was at the very, very top. Now, if when this is coming out of Sadoway Labs, when this commercializes, which is in the process of doing, um, uh, uh, it will offer what we call green steel, which has zero emissions, which will absolutely revolutionize the construction of our cities.
It's not yet commercialized?
It very soon will be. It has to go through ASTM standards, and that is occurring right now. Um, and Urban Anno, essentially, we're a research-based firm as well. So we're constantly researching new ways to reduce carbon in the built environment. And these are just some of our experimental projects. There's something called photovoltaic concrete, AAC, autoclave aerated concrete. And then
Photovoltaic concrete is producing energy?
yes, it produces energy. Yes, yeah. And this is just this is in Tertian, which is one of the largest data centers in the world that we were part of. It's just on the outskirts of Paris. Now we get into Helsinki. This is a fascinating data center because this is the first net zero data center on the planet. It's a very unusual data center. It's using immersion cooling, which reduces the rack size for data centers. What we have done is we have cladded that with vertical farming. So, for example, this is in Helsinki, where um, uh, um, um, they have to fly in their vegetables from the Netherlands. So a tomato in the winter in Helsinki costs about €1. And so what we're doing here in the city center is we're providing local produce at a very reasonable price. Now that is also wrapped with a public greenhouse. So data centers are all about heat reuse. So we're using the heat from the data center to warm the greenhouse, which So the data center, the heat coming off the data center is exactly the same temperature that a greenhouse requires. So we've wrapped, we have a wrapping ramp up around the data center that lands here on the roof, and this that becomes a cafe on the roof. Just some other shots. Now, this is again an entirely prefabricated data center. So when we talk about carbon reduction, we can think of it we think of it backwards. So we think of it right from how do we reuse the motherboards of the racks, right down back to the you're looking at a carbon fiber prefabricated structural system that can be later reused. This is Project Energos. You're looking at precast concrete panels. This is a net zero skin as well, with solar on the roof.
Looks pretty impressive, these data centers. Also
Yes.
the design.
Yes. All right. So now we get into get into the future. This is hydro pump storage. Uh, um, a data center hydro pump storage. So is this one in Toronto. Now these are SMR, small modular reactor data centers. And I believe concludes my presentation. I think I went over actually.
Thank you so much. So now I ask Suzuki-san to. Did you send me your presentation already? Oh, okay, okay.
Thank you very much. So, can I start? Yeah. Okay.
So Suzuki-san, like I said, we met also in Davos already 2 or 3 times, right? 2 times, and so Advantage Partners is the oldest private equity firm, if I understood right, in Japan, and recently they created a hydrogen fund, and Suzuki-san is in charge of the hydrogen fund, and he will introduce now about the activities, and then we can go into the discussion.
Thank you very much. My name is Keiichi Suzuki. I'm partner and head of renewables and sustainability of Advantage Partners. Maybe we can use this presentation then. Maybe next page and flip next page. Next page, maybe this is too much wording. So, okay. Advantage Partners is Japanese private equity fund. This is actually the oldest private equity fund in Japan, which means our founders started this business almost 32 years ago, 2 years ago. And so that's why our history of this business is over 30 years in Japan. And so far we raised 12 funds so far. And then we invested more than $5 billion into more than 100 companies. And then our employee around 150, 100 in Tokyo, in Toranomon area. And also the other 50 people are in Singapore, Hong Kong, Shanghai, and Mumbai. So we are pan-Asian activities. Okay, next page. And then we have a 4 product line. So in the top, Japan Buyout Fund is our flagship fund, which means our first and then longest history. We are operating now fund number 7, which is around $1 billion fund. We are investing in so-called mid-cap companies, mid-cap. And then also we expanded our practice to Asia. So in Asia, we are now operating fund number 2 and then investing into the Southeast Asia, India, and Greater China. And our third product line is it's called Private Solutions. This is investing in the listed companies, public companies. So and keep company public listed. This is not the activist type of fund. It's more engagement fund, or it's a white knight type of fund. Means we are collaborating with managers, management. It's the same capability as a buyout fund. Together with management, then we improve the performance for the company. Okay, and my team is called, again, Renewable and Sustainability. This is a new team, relatively new team. 4 years ago, we started this business. I moved from Mitsubishi Corporation, Japanese trading house. And in Mitsubishi, I was in charge of infrastructure, big infrastructure in Europe and Middle East. Like in Middle East, like independent power and water producing facility. It's a big plant, desalination, and then combined cycle gas turbine. And in Europe, lots of offshore wind business, total 2 gigawatt in Scottish offshore, Dutch, Belgian offshore, and typical onshore solar and wind and battery storage business. So that's my business career, and then I moved to Advantage Partners and starting infrastructure fund. And then, so difference from other product line, we can invest in infrastructure in addition to corporate, so which is new. And also our team can invest beyond Asia. For example, Europe, for example, North America, could be Australia, Middle East. So it's a global because sustainability is very global. Okay, and flip to the next page. This is a fund history, so it's okay. Flip to the next page. Next page, please. Next page. This is the office. Next page. Next page. Next page. Okay, so briefly explain our team. So this is only our renewable and sustainability team, and then the top 2 gentlemen are founders, Sasanuma-san and Richard Folsom. He's American, but 2 gentlemen started this company, and then myself came to Advantage Partners 4 years ago. I'm head of this team, and then my team is now, including me, is now 9 team members. People coming from infrastructure, a developer background. Some people come from corporate investment, buyout investment career. Some people are from McKinsey, EY, and KPMG, more due diligence, valuation, and then financial modeling. So those hard skill people. So it's a mixture of the people. Okay, next page, please. And then I want to talk about Japan Hydrogen Fund. So this is our first fund, actually, under our strategy. This is it's a decarbonization, energy transition fund, focusing on hydrogen and its derivatives. Before talking about the fund itself, I want to talk about the Japan Hydrogen Association. This is Japanese biggest private association focusing on hydrogen. Japan is very keen. Japan is very keen on the hydrogen, uh, and so this association is now the updated number of the members are 500. 500 companies and municipalities. So here is a 400 something, but now because 2 days ago there is a general assembly of this association, so now updated number is 500. So 4 years ago this association started, and then 2 years ago this association was incorporated as foundation, non-profit foundation. So since then, first the member companies are just 88, but now 500. So a lot of interest or participation from Japanese industry. And as you can see the logos, there's all big Japanese conglomerates, including manufacturers, including oil and gas companies, trading houses, steel makers, car makers, and then insurance company, banks. So basically, all of the industries are joining. So it's a Japan Inc. type of the group, and then chairman company is Toyota Motor, who is producing hydrogen car and also fuel cell. Toyota is really the a big promoter of the hydrogen, and also Japan is one of the biggest company in Japan. And Iwatani Corporation is also chairman company. They are industrial gas distribution and the manufacturer. So it's like a air product in USA or air liquide in Europe. It's a big industrial gas company. And then Mitsui Sumitomo Bank is also a chairman company. So 3 chairman company, and then 26 steering committee members and 500 members. So this association, the goals of this association, 3 things. One is how to drive the cost of the hydrogen down, which is not so easy. And then secondly, how to develop the demand. This is also, it's a chicken and egg, demand and supply, demand, supply. More demand, more supply, price can be cheaper. So it's a typical chicken and egg problem. And then number 3 goal is to break through this chicken and egg issue. This association want to have a fund to invest in the risk capital to the projects and companies in the hydrogen supply chain. That's why they create the fund. But who will run this fund? So they are starting process. They invite Japanese or non-Japanese GPs, general partners, is a fund manager, and then we raise hand, and we are one of them. We started my team, and then so this opportunity we want to get it. So maybe next page. Maybe 3 page more. I need to go maybe one more page. The last one more page. So sorry, I'm a little bit skipping because I want to explain the structure. Next page. Next. Sorry. Next. This page. Sorry. So should be this page in the front, but yes. So this is a structure. So okay, Japan Hydrogen Association invest, not association itself, but the member company will invest in this fund for Japan Hydrogen Fund. This is a Cayman company, a Cayman Limited Partnership. And then this Cayman Limited Partnership is also invested by GP, General Partner. And General Partner, my company, Advantage Partners, invest. And also we also, the partners also invest. And then we have the Advantage Partners, PTE, Singapore. This is a licensed advisor, licensed alternative asset manager. So this manager will give advice to the fund. And then this licensed manager sub-licensed, subcontract the investment advisory job to us in a Tokyo Advantage Partners Inc. in Toranomon, Tokyo. And also, so we manage all the investment related activities from sourcing and also proposal to the investment committee, and then execution, monitoring, and the final exit. And JH2A, Japan Hydrogen Association, also provide service to the fund, like introduction of the 500 member company. It says a lot. And also introduction to the METI, Ministry of Economy, Industry and Trade, METI, because we need a lot of discussion with METI, how to bring hydrogen society in Japan. And also association introduced us to the overseas hydrogen association, like European Hydrogen Council, and Australian Hydrogen Council, and also Houston Hydrogen Association, and so forth. So that's very important. And finally, Mitsui Sumitomo DS Asset Management. This is the asset management company. They do, it's so-called middle and back office business, including ESG evaluation. And also, it's so-called Japan angle evaluation. So they do all these checking. So these three service providers, and then we made investment. And back to the 5 pages back, maybe. Can you go back? Yeah, back 5 pages back, maybe. One more back. Yes. And currently, we raised around 500 million US dollar from these 14 investors. Toyota Iwatani is our anchor investor, SMBC, MEFG is also anchor. And Total is a French major oil and gas company. Total invested us. They are currently only non-Japanese investors. The others are all members of JH2A, but all the name DBJ, Japan Development Bank, overseas, the Japanese big construction management company, Mitsui Sumitomo Trust. So these members. But still, we are fundraising now. Our target is $1 billion. So $1 billion fund. So next page, please. So out of $1 billion fund, we want to invest all the value chain. You can see the pictures, all the value chain of hydrogen. Hydrogen and its derivatives, ammonia. Ammonia is hydrogen and nitrogen from the air. And then methane, methanol, and also it's called SAF, Sustainable Aviation Fuel. It's a kerosene, it's a light oil for the airplane. So all these, we call clean molecules, chemical molecules. All these clean molecules is our territory, our investment area. Producing them, and then transporting them, and storage them, and use. The use case is very important because demand is everything. Without demand, we cannot produce oil, right? We cannot invest. So use case is mainly three. So one is industrial use. So iron making. The professor also introduced Boston Metal, but green steel, we call green steel because steel is made from iron ore and coal. Because and then make a pure ferrous steel and CO2. This is a typical chemical process. But to make a 1 ton of pure steel, we need 2 tons of CO2. So it's a really the biggest emitter as an industry. So steel making is CO2 making, double. Ah, really? Sorry. I missed that first part. But anyway, steel industry, we need to do something. And also refineries and also chemical like fertilizers, nitrogen fertilizers create from ammonia. But currently it's so-called gray ammonia, black ammonia, which means positive fuel ammonia. But clean ammonia is made from clean hydrogen, right? Electrolyzers and power. And also transportation is a big area. SAF, as I said, airplanes, need fuel. And then in no way a battery can fly big planes. It's impossible. So we need a fuel, liquid fuel. So SAF is a sustainable aviation fuel. It's two types, biofuels and e-fuel. E-fuel is basically made of fertilizer, sorry, electrolyzers and water and power, clean power. So that we call e-fuel. And also maritime sector, big ship, big tankers or containers, those big ships going from Tokyo, Kawasaki to Rotterdam or Singapore, this is also cannot be operated by battery. It's impossible. So we need a fuel. So fuel can be methanol or ammonia. So these are two types of fuels that are well recognized as a next generation fuel. So decarbonized fuel. So that's the transport. And also big trucks, big bus, heavy duty car, vehicle can be operated by battery, but battery is heavy. So trucks and then heavy battery is too much because the Japanese road is not allowed. US road, I heard it's somehow heavy duty okay, but Japanese road it cannot. So big trucks can be better fit with hydrogen and fuel cell, like Toyota, like Toyota system. Compressed hydrogen and fuel cell. Go further, more 500, 600 kilometers, and then hydrogen is light, very light. So, needs some space, yes, but trucks and buses have some space, it's a big vehicle. So, and the power generation. Power generation is a, thermal plant like a coal plant or gas plant. In Asia, in Japan, we are talking about the coal firing. Instead of firing all the coal and all the carbon makes CO2, rather than we mix it 30%, 40%, 50% of clean ammonia. Then we can reduce 50% of CO2. That's the idea. This idea, not much supported by Europe and US, but anyway, Asia want to keep those thermal plants for some time. So then we need a co-firing. So this is this is a use. So, and our fund is a global fund. We can invest in Japan. We can invest in North America, Europe, and other world. And then I want to talk why hydrogen. Hydrogen is a really clean molecule, and the molecule is basically chemical stuff. And then this is they have energy. When the hydrogen linked to the oxygen makes water, but produce a lot of heat and the energy. So that we need. And then if you have only renewable power, power is electron. E minus. So that's it's an electron. That's electrical power. which is very important to decarbonize many things, right? Many things, but not everything. These use case, steel making, chemicals, transportation, those power and battery cannot solve. So only maybe half of the human beings' use of energy can be converted to the power. Currently, only one third, one third power, one third liquid fuel, one third gaseous fuel. So that's a kind of current composite. But we want to electrify as many things like home gas can be electrified, or so that's the first effort. But half of the energy human beings use need molecule, hydrogen and hydrogen derivatives. That's that's why we do this fund. And maybe next page. And then we have already made 3 investments, real investment. The first investment is a US company called Infinium. They are e-SAF developer. Again, SAF is sustainable aviation fuel, and then they make fuel from renewable power and water, and then using electrolyzers makes hydrogen and CO2. They procure CO2 from the industrial CO2 or biogenic CO2, and then mix it hydrogen and carbon, and then to make a SAF through chemical reaction. I don't want to go detail, but it's a chemical reaction in the process, and the 2 type of catalysts we need, but we make a fuel, e-fuel. It's a clean fuel, 100% non-CO2 fuel. So this is our first investment, and then next page. And this is their second plant. The first plant is already up and running in Corpus Creek in Texas. Almost 2 years of running. And then this plant is the second plant. This is in West Texas. This is a 500 barrel per day. 500 barrel per day. It's pretty huge. This is the world largest e-SAF plant. Will be, now under construction, but FID, final investment decision, was made already. This is very important. Final investment decision, FID, means investors decided to put big money. So this is invested because there is a customer. So customers are buying fuel, like airline company, American airline company, and then AIG is a British Air. These airline companies are committed to buy this fuel for many years. That's why the investment was made. And the second, next page. This is also similar e-SAF. Too much time? Oh, okay. All right, fine. Maybe. Maybe this we can skip, and then maybe the third one, next page. So this is our third investment. This is actually green steel project, green steel production project in France, southern France. So they have a electrolyzer plant, and also it's called DRI, direct reduced iron plant. So red rectangular part is our plant. So this is we are invested, and then together with these big names, Rio Tinto, world largest mining company, Siemens, Ecolab, Engie is a French big utility company. So these are, and also I'm a board member of this project, and then now we are under development, and then hopefully we want to start construction next year. Okay, finish.
Christian, when I get an opportunity, I'd love to ask you a few questions.
Yeah, you go ahead.
Well, I'll share my screen. You and I have been talking about very similar things when it comes to green hydrogen and also green steel. So I want to share my screen. I'd like to share with you this announcement again with my client SGH2 Energy, Dr. Robert Doe. Notice that it's the utilization of local biomass, which is waste, biogenetic waste, feedstocks, to produce carbon negative hydrogen. So not carbon neutral, but carbon negative hydrogen, calling it a blueprint for green energy integration. I just wondered, would that be of interest to you to learn more about that or to meet Dr. Robert Doe?
Our fund mandate is a hydrogen to make a hydrogen. We don't care about the color. Typically people say green hydrogen is electricity. Blue is gas to hydrogen, but CO2 captured, carbon capture and storage. And then biohydrogen is also possible. Bio gasification or bio waste. That's fine. And then for us, Singapore. So color doesn't care. We don't care color, but we just care a clean hydrogen, which means low carbon hydrogen, right?
Yeah. So the purpose of for that project in Japan is to produce e-fuel for vehicles. I think that is it. But my question to you from a PIF point of view, so the PIF was supposed to be conducted by the end of Q1, and it's now we're considering it at the end of Q2. Ultimately, my question is, how does your fund work without so for example, in the United States, the PIF is dependent upon the Inflation Reduction Act 45V subsidy. Otherwise, the cost of producing green hydrogen will jump up to the same price as producing gray hydrogen. So how in Japan or with your investment group, how are you able to operate without a federal subsidy? That's the
Yes,
ultimate question.
yes. U.S. IRA, Mr. Trump want to change 45B is a big problem for green hydrogen, unfortunately. But there's a 45Q, twin 45Q. This is taking care of the carbon sequestration, carbon capture storage. So this
CCUS.
CCS, this tax credit stays. Trump didn't touch because of the ExxonMobil, Oxy, big oil and gas people lobbied.
Well, yeah, no. Sorry, I'm not interrupting, but we know that CCUS is a cover for oil and gas, right? That they're very pro CCUS. All
ExxonMobil and then Oxy and then other big oil and gas guy want to keep CCUS, and that's why 45Q is okay, intact. And then carbon storage. And then the other one is 45Z. 45Z is a tax credit for the fuel. like SAF or methanol or liquid fuel. So this is extended. So this is good news. So 45B, Trump want to demolish is bad news. CCS, 45Q CCS stays, which is good news. And then 45Z extended, which is good news. Uh, uh, so in my view, Mr. Trump want to demolish everything, right? He's anti-ESG. Basically, he wants to demolish everything, right? You know, if you see the draft, 45Q stays, 45Z extended, so it's a little bit in the middle. And then green, so hydrogen 45B is at least, yes. And then assuming, and we don't know the result yet because senators now fighting back. A lot of lobbying now going on, and the senators want to put back some portion of the you know, not demolishing, but maybe extend a few more years, then stop, or you know, middle ground. You know, this negotiation is now undergoing, and then we don't know when it's finished. Trump want to finish by the end of the July 4th, but I don't think so. So that's the situation. And then, okay, then as a worst case scenario, when the 45B gone, but still we think blue ammonia, blue hydrogen, which means hydrogen with CCUS survive. And then Japan is the most likely now importing from USA blue ammonia from Texas or from Louisiana. That's a project which is going alive. Blue ammonia, green ammonia, and green hydrogen. Maybe we need to see. We need to see more. You know, this sort of is killed or not. Yes, that's true. So that is a USA. But when you look at and also tariff also matters. Not only for the green decarbon project, but also all projects. Even the fossil fuel digging, a lot of a pipe to the 3,000 meter down the sea. It's a huge infrastructure and steel. And all these things coming from Nippon Steel. It's a special steel. It's special steel. US cannot make. And then actually, US already demolished most of the blast furnace, which means in the US cannot make it. So then US need to import from Japan. And then if Trump want to put 100% or 50%, that US people pay.
Mm.
So which is I'm a little bit against Trump, anti-Trump guy. But I'm a pro ESG guy because I running this one. So, but anyway, all the U.S. infrastructure gone up. Data center too. Data center is steel. A lot of steel. Data center. And the Chinese people stop rare metal. And then Trump going back to from 200 to 10. Because he want to rare metal, right? All the rare metals are coming from China, unfortunately. So world doesn't move like Trump believes. That's my feeling. Chinese people doesn't care. They just stop rare metal and they just sell to the Brazil, Japan. All the Chinese products coming to Europe and Japan and non-US. So I don't know what Mr. Trump want to achieve. That's my view. But anyway, so European projects are moving. They don't care about tariffs. They don't care about 45B. In my view, it's a bit mosaic. The US is a bit uncertainty. Of course, Europe is also a little bit economic slowdown because of the European cars are not selling great. So, Japan, I think Japan, I'm positive about Japan because of the currently Japanese is called CFD, contract for difference. subsidy to supply to support clean hydrogen and clean ammonia, filling the gap between a gray and clean for 15 years. It's a budget approved by METI. It's a $20 billion, $20 billion.
Sorry, what was the subsidy called?
It's a CFD, Japanese contract for difference. In Japanese, nesa shien. Nesa, so price difference. Nesa shien seido.
And
Nesa shien seido.
and in English?
It's a contract for difference. Support from Japanese government, METI. And also METI also have one more subsidy scheme, which is supporting Japanese port subsidy to enhance the receiving facilities, tanks, pipelines in the port. Because hydrogen and ammonia is very new. It's different from liquefied gas or oil. So we need a new tank, or we improve the tank pipelines. So we need a lot of capex in infrastructure in Japan. Nagoya Port, Kawasaki Port, Kitakyushu Port, Shunan Port. All major industrial ports in Japan need capex. It's a lot of opportunity in Japan to make infra investment.
Yeah. So, Joe, do you want to have more topic?
I don't. I thought
Yeah?
that was a fascinating. I am very much in agreement with you. What I did not hear was the subsidy, the Japanese subsidy acronym that you said.
CFD.
What, say it again.
Contract for difference. CFD. CFD.
Contract for difference. Yeah. CFD. Thank you.
British, as a similar subsidy to British system to the same contract for difference, and the difference between the gray and clean.
Wonderful. Yeah.
Green, gray means fossil based hydrogen, and then clean means mainly green and blue. Blue is again fossil fuel but CCUS. So it's more cost. And the green means electrolyzer hydrogen, which is more expensive. So
I mean, we had nominated a company called Enapter. Do you know Enapter? They want to mass scale electrolyzers and make electrolyzers scalable and competitive. So I think finally China has caught up in this game, and finally Enapter had planned a big factory in Germany as well, and they also did an IPO, but they did not utilize the factory because China was actually ahead of the game and producing cheaper than they could ever do. So what do you think? I mean, would this, we need green hydrogen, right? So this would be the ultimate solution. So how can we make green hydrogen competitive, basically?
in Japan or in the world? In general, yes. China is very aggressive on the clean molecule. They are very aggressive on the solar panel. They dominate now. Almost 90% of the panel is coming from China, 0 from Japan. And then now, Mr. Xi Jinping is very much aggressive on the molecules, hydrogen, and then they are pushing the it's so-called alkaline electrolyzer. It's a type of electrolyzer, alkaline and PEM. Alkaline is a little bit old technology, but Chinese electrolyzers are cheap, very cheap, almost half price of European alkaline. And then so that's why, and then also China has a very large wind and solar, which is cheap again, so cheap power. So Chinese molecules are very complex. So Japan, China is a, and Western world, want to a little bit careful about China, right? But it's true, Chinese molecules are cheap. Japan, of course, Japan, I believe, I'm not a nuclear fan. I'm a little bit against nuclear, but in the end of the day, Japan needs nuclear for the clean power, unfortunately. And then also Japan needs offshore wind. This is struggling. This is very much struggling now. But anyway, Japan needs offshore wind more and more because onshore solar and wind is done, limited.
Yeah. Yeah.
It's only peanuts. So with the nuclear and offshore wind, Japan can produce certain renewable power means a certain volume of hydrogen. But that doesn't enough to procure all the Japanese citizens or industry needs. So I believe we need a sourcing from the US or Australia, India, Middle East. We need a portfolio. It's much better than oil and gas. Oil and gas only from the Middle East and then some specific area. But hydrogen can be from hydrogen only need a huge land for the renewable and then solar and wind resource and water. That's it. I think there's more opportunity we can Japanese people can find and then bring to Japan. That's what we need. And then US and Europe is a big continent and they can produce by themselves. But currently, China and Texas is the cheapest place to create a molecule. Europe is a very, electricity price is not cheap. Only Nordics, Spain, okay, Spain and the Nordics is the only place you want to have a molecule plant.
So we actually we are a little bit over time now.
Yes,
And,
yes.
We also have the networking here.
Yes.
I would like to maybe ask a kind of closing question, which I'm always very interested in, to see kind of a future vision. And I want to have a short and concise answer, basically from both of you, which would not be probably a final answer and shouldn't be perfect or something like this. But I want to know how you view the future of energy. I mean, we have heard now a lot of different types of energy, solar, wind, hydrogen, different gas, blue, gray, etc. And we have nuclear energy. Maybe we have fusion energy in the future. So maybe, and is it a mix? Is it a kind of a mixed grid, or is it a decentralized structure? Maybe if you can try to be as concise as possible and answer, maybe from Joe, what is your future vision for energy, basically?
Yes. First of all, I would like to thank the second speaker. That was a remarkable presentation. So a concise answer from me would be we need to utilize and generate as much clean energy as possible. And that would be nuclear. Because of what happened at 3 Mile Island, the stigma of nuclear is now no longer in the United States. So nuclear, green hydrogen fuel cells, hydropump storage, and what we didn't talk about is geothermal, which plays a very important part. And I think that with those, and of course, solar and wind, that combined solar on or wind on land and on sea, especially for Japan, which has very little land mass. That is a great answer. There is some challenges with solar at sea on the seabed floor. And you also mentioned desalination. That is very problematic for for the sea itself. But those are my top clean energy solutions for around the world, and I think we're getting there. So.
Thank you. And by the way, Joe has a very good blog which he's publishing every week. So I recommend to also connect with him on LinkedIn, and then also subscribe to his newsletter.
Yes, my future view on the energy is yes, as same as the professor. You know, I think it's we are heading to the zero carbon. We are zero emission, net zero energy. Yes, which is more expensive than fossil fuel. Yes, that's of course because fossil fuel is just dig and take it from the earth, right? It's a loving from the earth. But the making EFL is a costly. But I think that all the human beings need to think about how to cost down and then as cheapest as possible. And then and also we also need to think about how to minimize the energy consumption. AI is yes, AI is you know, it's a big I think controversial things. But you know, we want to. I personally want to think about how much energy need to consume for our, you know, asking to computers. I'm fine with current Google search. I am fine. I am fine. But if you ask the AI and the 10 times of the power for one question, I don't get it. But anyway, human beings need to think about how wisely we can use the earth. That's my view. And then also my generation is okay, but my kids generation, their kids generation and their kids generation, we are talking about 100 years or something. Like we are not talking about 10,000 years, which is some people say we will have ice age again. When? Which is 50,000 later. Which means how many children do you want to have? But I'm just talking about my children, maybe 3 generations, 100 years. And then Tokyo can be unlivable maybe in 20, 50 degrees, 40 degrees, normal temperature. We have it. So I'm really, in that sense, I'm really so that's why I'm believing more sustainable energy treating future and more friendly earth, you know, earth, how to call it, how to use the earth resource people. That's my view.
Thank you. Thank you very much. And that's good final statement, I think. And yeah, so treating the earth, and also at our Sustainable City Summit, we heard we had a meditation about being a good ancestor. So what we leave behind is very important, and we can, in our generation, we can do things. Unfortunately, at the moment, there are very ugly things also happening in the world. I don't know if you have heard about Israel and Iran. It's very concerning what's happening, but hopefully this comes to an end and it's only temporary, and then we can go into an era where we have all these very fascinating new things with clean energy, with clean earth, and with new materials and new buildings which are made from energy efficient materials and sustainable materials. Great. So thanks everyone. Thanks everyone, and yeah, very good session today. Thank you. Thanks, Joe, for getting up early. You might have your breakfast now. So
Thank you,
Thank you.
Christian. Pleasure. I'll sign off now. Thank you so much.